All right, thank you. Thanks once again for being here on time. I really appreciate that. I've emphasized before how important it is when we've got a lot of material to cover and when it's a real distraction having the door at the front of the classroom. So thank you for being here on time. Let's take a look at a couple of announcements here before we get into the new stuff. First of all, that introductory assignment that I told you about in our previous class on Tuesday, that's the one where you're kind of just telling me a few things about yourself and how you prefer to learn, that sort of information. That's due on Friday. And so what you should do is type up your response to the questions and upload the document before 5 p.m. at MU Online. And don't email it, don't print it out. The only way to submit the assignment is electronically on MU Online. Do you have a question?
Yeah, did you want that as a Word document or a PDF file?
Either one is fine.
Okay.
Yeah, it'll display either one inside the system. Okay, your second homework assignment related to interest, that's going to be due a week from today. And the submission deadline is a little bit different from that one. Although you've got until 5 p.m. on Friday for the first assignment, you need to submit all the rest of them through the semester before class on the date indicated. So that's due on Thursday the 30th at 8 a.m. And the PDF for that is on MU Online. If we go to our course web page, then I'll show you where you can find it. Same place as the first homework assignment. By the way, I'm recording this lecture, although I'm using a different microphone than usual. Ordinarily, I'd be wearing a lapel microphone, but I think the battery died over the summer, so I hope, yeah, it looks like I'm getting audio out of this webcam. It probably won't sound as good. All right, so for the class website, you go to Engineering 222 and immediately takes you to the important stuff, the course content, and you see here's homework 2, interest. And so you can click on the PDF to see what the assignment actually is. Some of these are problems that I made up. Some of them are from the textbook. And please remember that for these textbook problems, I know that there are PDF solutions out there on the internet, but you should never even consider accessing them. Do the problems on your own. It's considered cheating if you even look at the solution online, much less copy it. So this is the assignment. As the announcement slide says, that's due on Thursday the 30th before 8. Any questions about the homework assignments? Okay, so this homework assignment number 2 is going to be something where you're doing hand calculations, but you have to submit a PDF of it. And so you can use a flatbed scanner if you've got one. That's probably the highest quality, but I wanted to show you that app that I told you about, Cam Scanner. And so it's an app that you can install on your phone, and you begin the app, and it's just like taking a picture. So let me do a demonstration here. I've got one of the in-class exercises from last time. I'm going to begin a new document, take a picture, and you can set like little lines to help you set it up straight if you like. But the nice thing about this program is that it kind of automatically detects the edges of the page, and it automatically detects any keystoning or skew. So you click yes when it says that it's detected the right thing, just a little check mark. And then at the bottom, it gives you some options, like do you want it color, do you want it in grayscale, do you want it to be lightened or darkened. I just select, scroll to the side, black and white. And so once I click the check mark for black and white, and then it shows you the document, and you could do another page, and it will put the second image in the same PDF file. So you can do another one and another one and another one. It just builds this single PDF. But if I drag down, then what it'll do is it'll refresh and it will send it to the cloud. So you can have it export the PDF on your phone itself, or if you go to the website, it's backing it up to the cloud. So you can see now this little, it was doing the refresh thing, and that's the PDF that I just took. And it creates a document with pretty good quality, and I think there's an even higher quality option I could have set it to. But here I'll say download, and I want the PDF of that. And so now I've got a document that I could save at a location that I'll be able to find again, you know, like maybe my documents. I'm just going to put this in a temporary folder because I don't necessarily want to see it again. And once it's downloaded, you can put it on MU Online. And let's just take a look and see how that turned out. Okay, so that's absolutely sharp enough that the grader would be able to see it. It's not perfect, and it's not as good as it would look on a flatbed scanner because you can see it's a little bit warped, and you have to be careful. See, the paper has a bend in it, and so some of the paper is up off the table, and that's going to mean that the focal point isn't all even. And so you can get a better image if you kind of make sure that the paper's laying down flat, and it does a fine job though. This would be a good enough image quality that the grader would be able to read it. But some of the things that degrade the image quality is if you write really lightly, or if you're scanning in color, then it will use more data on representing the colors than on representing the sharpness of the text itself. So always choose black and white, and that'll make the file sizes smaller, and then the image turns out more sharp, and there's a better contrast as well. All right, so that's CAM scanner. It's pretty easy. I hope it won't be too much of a nuisance, but the other thing that's kind of nice about submitting your homework electronically is that there's never an issue with lost papers or a professor who put it in a stack in his dirty office, or delays in getting the papers from you to the professor to the grader to the professor back to you. I mean, it's just as soon as the grader finishes scoring your work, then you see your grade instantaneously, and so it kind of removes a lot of the lag that used to be built in if you're submitting things physically on paper. And the other great thing is that then you've got this electronic record of your work through the entire semester, and you can kind of build a portfolio of what you did for reference in the future when you have to study for the FE exam, or when you're working on senior design. You need to know these concepts. It's just a lot easier for it to be available to you. All right, so that's CAM scanner. Today we're going to be working through an in-class exercise that I prepared, and I'm going to be doing a little bit of lecture at the beginning here related to some topics on interest rates. And we're going to learn some of the symbology that's frequently used in problems having to do with the time value of money. And I'll tell you what that time value of money means. And then there's also, in addition to a standardized symbology for breaking down problems and assigning variables, there's also a standardized graphical approach to showing when money is coming in and when money is coming out. And that standardized graphical approach is called cash flow diagrams. Okay, so any questions before we move on? Please feel free to interject if you ever have questions. I think through the semester we'll probably get more comfortable with each other to where you won't maybe feel intimidated to raise your hand when something I've said isn't clear. But please feel free to jump in if you've got a question. So one of the reasons why this course is important is because it will give you the tools and the information that enables you to compare design alternatives. Most of the time in engineering, there's more than a single solution that could be used. And we need ways to identify which solution is best other than just maybe aesthetic preferences. You don't just go with which solution is prettiest, but we want to maximize efficiency. And sometimes when projects are going to take a lot of years, or in cases where revenues won't be received until many years in the future, money in the future, for reasons we'll talk about later, future dollars are worth less than dollars now. And so we have to have a way of accounting for that. And so engineering economy allows you to compare design alternatives even before a project is initiated, so you can find out which one is best before it's too late. It gives you a way to quantify costs and benefits over time. And I know that many of you probably have a sense for inflation already. Maybe your parents have told you how cheap a gallon of gas was back when they were in high school. And so that's one of the ways that people are often acquainted with inflation, is just that the price of goods seems to be continually going higher and higher. Because of that, because of the time value of money effect, it makes it like comparing apples and oranges whenever you've got a project that has a different time frame. If there's one design alternative that's going to take 2 years to construct and a different design alternative that takes 3 years to construct, that difference in construction duration leads to some imbalances that otherwise, if we don't have these tools, makes it impossible to compare on an equitable basis. So for instance, if you have construction equipment, as an example, if you have a small steamroller and a big one, then either one of these has the ability to smooth out asphalt, but you have to know which one is going to be more efficient based on these time value of money factors partly. There are other things as well, depending on the area that's going to be constructed and so on, but this is just an illustration of an instance where you're going to have to compare alternatives and identify which is more efficient. Now, another reason why you take this class has to do with the agency that accredits your degree. Part of the reason why employers are willing to hire our graduates is that our degrees are ABET certified. ABET is the accreditation board for engineering and technology. And ABET visits campuses and essentially assesses the quality of education that's delivered. They make sure that the graduates are meeting objectives. They conduct audits on the degree and make sure that you've taken the classes that are required and so on. And so one of the things that ABET says is that students should prepare for a profession where the knowledge of math and science gained by study, experience, practice, applied with judgment, develop ways to utilize economically the materials and forces of nature for the benefit of mankind. So this is kind of explaining what engineering is. But engineering isn't just solving problems with math and science, it's solving problems with math and science economically. Anybody can build a bridge if you use enough steel. If you make every girder 3 meters thick, then the bridge is never going to fall down. But then maybe the society can only afford the bridge and not have enough money left over for the sewer system and not have enough money left over for the hospital. So economically solving problems is a really big charge that engineers have. And so what you'll learn in this class is some of the tools that you can use to analyze alternatives to find out what's the most efficient use of resources. Okay, I've mentioned this in our previous class that I'm going to be giving you a short PowerPoint lecture at the beginning of class, and sometimes we'll have examples on the whiteboard, but maybe the more important part of the class is the in-class exercises that I'll bring for you. And that I consider that more important because I think that's when the students get engaged with the material. So because of that, you have to bring a calculator to class each class meeting. There will generally be enough space on the in-class exercise paper for you to do your calculations, but it might also be helpful if you have some scratch paper to do just some side calculations. You can usually do this with a classmate. There will just be a handful of problems. And later on in the semester, we'll switch from predominantly hand calculations over to working on Excel. And I see some of you have computers here today. I sent out a message yesterday. Did everybody get that about computers? So I'd encourage you to start thinking about it if you don't already have a laptop. It's not a requirement, but it's time, basically. If you're planning to buy one anyway, it's time. It doesn't have to be a fancy one. I was walking around Walmart over the summer and I saw they had a laptop for $189, and that one would be fine for what you're going to be doing as an undergraduate. Okay, so let's talk about interest. Interest is a fee that you pay for the privilege of borrowing money. The interest rate is an expression of how much of a fee you pay as a period of time. And so here is an illustration that shows the difference in perspectives that can arise. When you are paying interest, that means that the perspective is you're the borrower, and let's say in this case you're getting the money from the bank. So the first transaction is that the bank provides a loan, and you repay that same principal. The principal means the original amount, plus interest. And the interest is a percentage fraction of the original principal. Now, this is a different perspective. Sometimes individuals are going to loan money either to the bank or to a corporation. So if you as the individual are making a deposit, that deposit can be thought of as a loan. You're making a loan to the bank. Or if you're giving money to a company by buying their bonds, you're providing a loan to that company. And so they will repay you the original principal plus interest. But we call it a little bit different. From the perspective of the investor, rather than being an interest rate, sometimes we think of that as the rate of return. So the difference in these two phrases is just whether you're the borrower or whether you're the investor. I see some of you have found the notes online. That's great. And if you prefer to take notes by hand, that's fine too. But just as a reminder, the PDF of all of these notes is available on MU Online in case you want to print it out or take notes electronically on top of it. Okay, a couple of important terminology items here. As I said before, interest is the manifestation of the time value of money. And so that phrase in bold, that's kind of a standardized phrase that's getting at the idea that dollars in the future aren't worth as much as dollars now, because inflation is making things more expensive in the future. So $10 now can buy more than $10 in a few years. You know, in a few years, after prices went up, you won't be able to buy as much stuff with $10. And so what that means is that the $10 now is more valuable than the same number of dollars in the future. So interest, though, is the fee that you're using for the privilege of using someone else's money. You can also think of interest as in a transaction where you make a payment to the bank as a deposit, and then in the future you get more back. The difference between the principal amount and the final amount is the interest. So here's that formula. Interest is the difference between the amount that you owe now, this is now from the perspective of the borrower, versus the principal. And if we express that as a percentage, here's the formula that you can use to calculate interest rate. So write this down. You're going to need this formula for the in-class exercise I have for you today. The interest rate is the interest accrued per time unit. Now, by default, most interest rates are expressed as an annualized rate. So usually it's expressed per year. But there are some situations where the interest rate is expressed monthly or even daily. Credit card companies, for instance, are kind of notorious for trying to conceal what the real interest rate is that you're paying, and so they'll express the percentage on a different time basis than annual, which is kind of the standard. So they'll say, oh, this is only 3% interest per month. You know, they'll kind of whisper into their sleeve the per month. So you think, 3%, that's not bad, but really that would be more than 36% per year if it was compounding monthly. Okay, now remember there's a difference in perspective, but the formula is the same if we're thinking of rate of return. Remember, rate of return is when your perspective is I am the lender now. You know, if you are the person who's loaning out the money and is going to get more back in the future, that means you're the investor. So the rate of return is the interest rate, the interest amount accrued per time unit divided by the original amount times 100. So it's the same formula, but we're just calling it now rate of return because we assume you're getting the money rather than paying it out. Any questions about these formulas? Okay, so like I mentioned previously, we sometimes are going to graph out payments and inflows of money. And we do that with a cash flow diagram. And so the value of graphically representing money flows is that sometimes in a word problem where it's just a block of text and it's telling you when money came in and when money come out, it's hard to visualize what happened in the same way that a succinct diagram can illustrate that. So I'm going to pause here and we'll start on the in-class exercise, the first page of it, and then we'll come back and we'll hit more about the cash flow diagrams. I'll tell you some of the standardized things that we use for cash flow diagrams. For this one, just the first page is what we're going to be working on. And so that means the front and the back of the first paper. So it's problems 1 through 6. You'll notice you don't need to write your name on this one. I'm going to let you hold on to this. I'm not going to collect it like I did for the in-class exercise we did in the first class. But my suggestion is to work with a classmate on this. Don't try and solve it alone. Just work through it with someone who's sitting near you or someone you know in the class. And then what I'll do is I'll put the solution up on the screen, and I'm going to be circulating around. I have the answers to all the problems. If you want to check it after you've done it, I'm more than happy to let you know if you're on the right track. Let me interject with just a couple of things before you move on. So first of all, problems 1 and 2, the solutions are there on the screen for that. So if you start with 20,000 and get 5%, that 5% of 20,000 means you get an extra 1,000 as the interest amount, and the combined total that's owed after a year is 21,000. So that's kind of using the formula that we saw from the perspective of you're the borrower and the bank is the investor. But now in problem 2, since you are investing, we're calling it a rate of return. And you put in 200,000 and they pay you back 212. Then that means that the interest was the difference between the ending and the beginning. So 12,000 is the interest amount, and as a percentage, that's 6%. Okay. Now, on that problem 3, the first thing you have to do is find the value today in AED. That means United Arab Emirates dirhams. And ISK, that's Icelandic krona. So let's say that there are, you get 35.25 Icelandic krona for each United Arab Emirates dirhams. So you find out how many dirhams are there today. And the formula that you're going to need to use for this second part to find out how many dirhams there was a year ago, the total today is the initial amount plus the initial amount times the interest rate. This looks a lot like the formula that we have been using already. So the total amount today, once you convert it from krona to dirhams, that'll be the total amount today. And the initial amount is what you're trying to solve for. So like if we were thinking in algebraic terms, that's x. And then plus the initial amount x times whatever fractional interest rate, 3%. 0.03. So you're going to have this total today. You'll get that amount from the currency conversion, and then it's basically 1.03x, and you're solving for x, which was the starting amount a year ago. Okay, so that's a little hint to get you over the goal line on problem 3. For problem 4, you're going to have to draw a sketch of a cash flow diagram, and you've never seen a cash flow diagram before, but let me give you a hint. These cash flow diagrams, it's going to be a horizontal line, and you put tick marks on it to represent every time period. And in case, on the problem 4, each of these tick marks represents a year. An arrow above the line means money comes into you. So if you get money, draw a scaled line up like an arrow, and if you're paying money, draw a line down below that time axis. So that's some basic information about cash flow diagrams, so I just want you to sort of give it a try, and then you'll also need to do cash flow diagram again on the back side of the paper. So remember, we're just focusing on the first sheet of paper for now, and then we'll do a little bit more lecture stuff before starting on the second sheet of paper.
It's the same that we just
Does anybody have any questions for problems 3 or 4? The solutions are up on the screen there. So the suggestion was to first of all do the currency conversion to find out those Icelandic krona, how much is it worth today in dirhams, and then backing it out to a year ago, you have to say, well, I know that the value today is 1.03 times what the value was a year ago, so that means the value today is 1518.24 dirhams. And then the idea with this cash flow diagram is that if you get money, so today you receive 10,000, so you're receiving it, that means it's an inflow. So you do a vertical line upward. And then 1 year from today, there are 4 annual payments. So that means this line from 0 to 1 is the first year. And at the end of the first year is where we put that tick mark for year 1. And through most of the semester, we're going to have the assumption that if you have like a business, for example, and you want to represent the revenue you received during a year, then just to simplify that, we'll assume that you receive the revenue at the end of the year. That's kind of a standard assumption in a lot of these problems, is an end-of-year costs or end-of-year revenue. So you get the payment to the bank at the end of year 1, the end of year 2, 3, 4, and rather than write 3,300 over and over again, I just made these lines roughly the same length and then have the amount that applies all of them, 3,300. All right. So I ask you to consider a few things on problem 6. And in case you haven't got to that yet, I'm going to pause this recording and give you some more time to work on problems 5 and 6. Okay, if you're still working on problems 5 and 6, that's okay. You can keep writing on your paper as I just go over a couple of things. But I know that a lot of you have finished, so I want to show you the solution. All right, so problem 5, I'm asking you to do a cash flow diagram again, but I say including labels, and we haven't talked about labels yet. So let me show you the solution, and I'll tell you what I mean by this labels thing. The cash flow diagram for this one is that you enable features. Okay, you save 10,000. At the end of each year for 6 years, and at the end of the 7th year, you withdraw the balance. The amount is not yet known. Draw a cash flow diagram from the bank's perspective. So you got to be careful. I threw in a little curveball at the end there, because if the cash flow diagram had been from your perspective, then it would be the mirror image of this. So you need to be careful, like on a quiz or an exam or a homework problem, that you definitely understand what perspective you're drawing. So the bank's perspective is that they get $10,000 deposits 6 times. And so this is the arrow upward is them receiving those $10,000 deposits 6 times. And you'll notice that I've put A equals 10,000. Any speculation what A stands for?
Annual.
Exactly right, annual. And so what that means is, since the amount is the same, this is what we call an annual series. If the amounts had been different every year, I wouldn't have labeled it 10,000, and I'd have to write the individual amounts. When there's just a single amount in the future, then we give it the label F. So here you can see that F is unknown. So that means it's some single future amount. But A is an annual series. So if A is annual, F is future, any speculation on what we would write if there is an amount in year 0 like there was? P. There it is. I was going to hope that you could guess, but I forgot I had written the label on the previous one. So if you have money at year 0 is present value. So P is present value. So those are that's the beginning information about these labels that you need to know. Okay, so now let's talk about bank interest rates. What if you looked up online the interest rates for a bank? And that sort of information is available. You can go to the Fifth Third Bank or Huntington Bank, and they'll post their rates online, and they'll tell you how much they're willing to pay to people that deposit money into a savings account, and it's usually pretty low. And then the rates gradually go up from there. You know, the money that they're paying out is always going to be less than the money they're receiving. That's how a bank makes profit. So I make a deposit to the bank, and they're giving me 1.65%, and they use that same money to loan to someone to build a house, and they get more money back, and so that they can pay me a little bit, and then they keep the difference between the two. Okay, so first of all, I asked the question, why might the mortgage rate be higher for a 30-year loan compared to a 15-year loan? What'd you write for there? Any speculation or thoughts on why the bank charges 4.29% for a 30-year loan versus 3.5% for a 15-year loan?
Time value of money. Yeah.
Time value of money? Okay, what do you mean by that?
It's going farther into the future, so the money's going to have even lesser values. They have to make more for it to even out.
Okay, absolutely. Now, part of the way that they account for the time value of money is they always charge more than they expect the inflation rate to be. So if they think that prices and therefore the erosion of a value of a dollar, if they think the inflation rate's going to be 10% per year, they wouldn't loan money out for 4.29%. It's always going to be inflation plus some extra. And so part of the difference between the two is probably that they think that, you know, over the course of 30 years, how are you going to predict what inflation is going to be? There's some uncertainty there. And there's more uncertainty trying to predict a 30-year period than a 15-year period. And so part of why they're charging more for a 30-year mortgage is just that they think that it's possible inflation could go up during a 30-year period more than it would during a 15-year period.
There's a key word missing there for the interest rates, though. Fixed.
Fixed, right. Yeah, if you are borrowing money for a house, there are adjustable rate mortgages, which is really scary, where you only have a certain period of time that your payments will be the same, and then the payments could go up. But here, this is assuming a fixed interest rate per year during the entire period. All right, question B. Why are auto loans higher than mortgage rates? Now, an auto loan presumably is going to have a shorter time period, so there's less uncertainty having to do with maybe inflation's going to go up during the 5 years of your auto loan. But think about the nature of that loan. Why would the bank want to earn more money back when they're loaning you money for a car, on a percentage basis, that is, than for a house?
Smaller loan amount, and it's a riskier loan.
Okay, so first of all, those are both excellent points. Let's break that down into pieces. First of all, it's a smaller loan amount. And so they want, you know, there's still a lot of paperwork. It takes time of the bank employees. And so, you know, a house is maybe $200,000, whereas a car is maybe $40,000. And so they want a greater percentage just to cover the transactional costs. So that's part of the reason why the percentage rate is higher. But then you said it's a riskier loan. What do you mean by that?
I mean, it's a car, you know. I mean, it could be repossessed, it could be totaled, and, you know, they could sell it, they could stop making payments. I mean, there's a lot of variables.
Right. So the value of a vehicle is less durable than the value of a house. And when you borrow money for a car or for a house, you're not really the owner. The bank's the owner. And if you don't pay them on time, they're going to take the thing back from you. The item that you purchased is collateral, right? And so house is a more stable, less risky collateral than a car, because as he mentioned, you could crash a car. Very few people crash their house. Sometimes a tree could fall on your house, but the collateral loses value in the case of an automobile, whereas houses are generally increasing in value. Their prices go up over time. So risk.
And a car depreciates very quickly.
That's right. Yeah. So, you know, after a couple of years, what the bank is going to try and repossess doesn't have as much value as it initially did. So the value of the collateral is decreasing. As he mentioned, the word for that is depreciation. Excellent points. So with those ideas in mind, now in part C, what about credit cards? Why is the rate astronomical all of a sudden? What's that? Okay, so the amounts are less, and we've already talked about how, as a percentage, if the amount is less, the interest rate goes up because of the nuisance of it. You know, they want a greater percentage because there's still some transactional costs. So that was part of it. And the other idea that we talked about before is risk. So what about risk?
A credit card has little to no collateral with it.
Right. Yeah, think about what you buy with a credit card. You buy a sandwich, right? I mean, the bank can't repossess your lunch. It's gone. You buy a flat screen TV. Maybe they'll try and send a guy into your house and take the TV off your wall, but it's not going to be worth as much as it was when you first paid for it. So it's considered an unsecured loan. There's no collateral. So it's more risky, higher percentages. All right, great. Any questions on problems 1 through 6? Okay, so here is a little bit more information about the symbology that we're going to use when doing cash flow diagrams. Sometimes a problem statement will tell you the interest rate, and so what you should do in the cash flow diagram, it doesn't matter where, if it's above the line or below the line. If you know the interest rate, just say I equals, let's 3%. Just put it somewhere in the sketch as a reminder. If a problem has a specified number of years, let's say that payments occur over, then we call that N. Now N means the number of periods, strictly speaking, because not all cash flow diagrams are going to be on an annual basis. Sometimes payments are monthly and cash flow diagrams are monthly, so N is just referring to a number of periods. And so here's another place where you need to be careful in reading the problem statement. You know, it's not just the perspective that sometimes can get you into trouble, but it's also whether the periods are quarterly, monthly, annual. Usually it's annual, but don't let that give you a sense of complacency. You need to always make sure you understand what the period duration is. We already talked about present amount, future amount, and annual amount. So if we were going to break this problem statement down into its symbols, you borrow $10,000 at 6% compounded annually to be paid back after 5 years. How much must be repaid? The way that we can translate that and assign the variables, like you have to do that in a homework problem, by the way. So this is practice for that homework problem. You'd say P is 10,000 because that's some amount now. That's a present amount. The I is 6% per year. The N, the number of periods here, is 5 years, and what we don't know is the future amount that has to be repaid. So that's how we would kind of break down that problem statement into its appropriate symbols. We're drinking from the fire hose today. This is lots of information, I know that, but you'll get a sense for how to translate these problems into cash flow diagrams, and then it'll come so naturally to solve the problems. You won't even remember how these kinds of things used to be challenging at all. It'll really become second nature within probably 2 weeks. Now there are different types of accounts out there that you can put money into when you are working with a bank. And let's talk about that a little, because the type of account you put money into reflects the interest rates that you'll pay and the interest rates that you'll receive. First of all, a checking account is oftentimes not going to receive any money back for how much you put into a checking account. There's typically little or no interest paid, and that's because you're using it for frequent withdrawals. And so any transactions using a debit card or checks or transfers, deposits, that usually goes in and out of a checking account. Whereas a savings account, it's assumed that the money's going to stay in there a little bit longer, and as a result, the institution is going to pay you an interest, a privilege for holding on to that money for you. And nowadays, the interest rate on savings accounts, you really have to kind of search around a little bit to get more than 1%. But if you're careful, you will find a savings account that pays 1% or more. There are also something called money market accounts. And money market accounts are kind of a hybrid between a checking and a savings account, with the exception that they usually require higher balances than an ordinary savings account would. And you can still write checks out of a money market account. A certain number of transactions per month would be okay. You can't write an unlimited number of transactions, but they usually pay higher interest rates than an ordinary savings account would because of the deposit amount minimums. Maybe you've heard of a CD before. A CD is a certificate of deposit. And a certificate of deposit is an agreement between you and a bank that you're going to leave money in the bank for a certain minimum period of time. Why do you suppose that would be important from the bank's perspective? And in fact, they pay more if you put it into a certificate of deposit than they'll pay you in a savings account. So if you say, I'll leave $10,000 in for 1 year, the interest rate that you'd get back for that fixed term deposit would be more than if you just put the same amount into a savings account. So why is the bank willing to pay you more if you promise to leave it in for a certain period of time?
Insurance for them.
What do you mean insurance for them?
Because they use your money like it's theirs when they have it. So
Right.
if they're guaranteed they'll have it for a year and you can't pull it out, like if I just have a savings, I could go out tomorrow and pull it all out.
Exactly. So he's making the point that in a savings account, they don't know exactly when their depositors are going to take it back. And so they can't loan out your money with as much confidence if they don't know when they have to give it back to you. And so they don't want to tie up your money in a 30-year mortgage if they're worried you're going to ask for it back in a month. Whereas in a certificate of deposit, if they have confidence that a certain number of their reserves has a certain deposit guarantee as far as the time frame, then they can invest that in higher yielding opportunities for them, and so then they pass along some minuscule fraction of the additional profits. So a CD will pay you back more than a savings account for that reason. Now, just as a reminder, all of this information is also found in your textbook. And if you want to get an A in this class, if you want to be a good student and have strong habits, my suggestion is it's very important to follow along in the textbook and not just rely on what you hear from me. What you hear from me is not going to be enough information for you to really become a master of this topic. We only have 75 minutes twice a week, and so that's just barely enough time for us to go over some of the minimum concepts. But if you want to have a strong grasp of the information, then you need to also be reading the book. Okay, a debit card is a piece of plastic that allows you to withdraw money from a checking account, and the money that you spend with a debit card is your money. Whereas when you spend money using a different kind of piece of plastic, a credit card, you're spending the bank's money, and you have a promise and an obligation to pay them back a minimum amount each month, but eventually you'll pay back all of that money and more because the interest rates on credit card purchases are typically very high. Has anyone rented a car before and seen that almost all rental car places have a little sign that says, we don't really like debit cards? Yeah, if you try and rent a car with a debit card, that makes the rental car agency a little uneasy because most people don't have enough money in their checking account available through the debit card to cover like the damage to a vehicle that could happen if you were in a car wreck. Whereas a credit card, usually most people have enough additional credit available on a credit card that they could pay for the damage. And so that's sometimes the difference between a debit card and a credit card becomes most obvious when you're trying to either check in for a cruise or rent a car, things like that. A mortgage loan is when you're first purchasing a house or property. It's a loan that you take from the bank. A home equity loan is related but a little bit different. If you have made some payments on your house, and it's not necessarily that you own it outright, but if you have what's known as equity, meaning that the house is worth maybe $200,000, but the loan that you owe back to the bank is only $150,000. that would mean that you have $50,000 in equity. The difference between its value and the amount you owe, that's equity. And once you have some equity, you could take out a loan against that value. And a home equity loan is used by homeowners for things like repairs to the house, home improvements, sometimes medical bills or college tuition. And so home equity loans, since they're secured with a stable thing like a house, making a purchase with a home equity loan is a much better idea than making that same purchase with a credit card, because the interest rates would be so much lower since it's a secured loan. So, let's say, for instance, you want to put in a really nice fireplace at your house and it's going to cost $10,000. It would be better to finance that through a home equity loan than to finance that through a credit card, because the interest rates would be lower. Okay, in the time value of money, the amounts in the present, value of a money amount now, are sometimes labeled P for present, or PW for present worth, or PV for present value. The abbreviation that's used differs from textbook to textbook, and one of the things that you're going to face in the future for taking the Fundamentals of Engineering exam, these time value of money calculations will show up on the FE, and so you can look in the FE reference manual and find all of the same equations that you're going to learn through this semester. Later on in the semester, we're going to take series of amounts with a cash flow diagram, and we're going to take it all to the present. And sometimes when we do those calculations, that's called a net present value or a discounted cash flow. That just means taking all of the money to times 0. You can also compound amounts to the future. So that means you're projecting certain amounts now, or let's say in year 1 or year 2. You can move all of those amounts in a cash flow diagram into the future, accounting for the time value of money. And we've already also talked about an annual series. A means an annual series. Sometimes that's called annual worth rather than just annual amount. The thing that you have to keep in mind is that for it to be an annual series, the amounts have to be consecutive and they have to be equal. So by consecutive and equal, what I mean is, let's go back to the diagram here. If there had been a gap in year 3, then it would no longer be a continuous annual series. There would be an annual series inclusive of year 1 and 2, and a different one 4, 5, and 6. But if there's any kind of a gap, then that breaks the annual series. Or if the amounts are different, then that's also not an annual series. So it has to be consecutive and equal. And then the typical assumption is that the end of the period is when we either have the inflow or the outflow. It's at the end of the month or end of the year. So here are those variables again, commonly used symbols that we'll put down on our cash flow diagrams, and we've already talked about each of these. Money coming in, which we put on the top of the cash flow diagram, that can be revenue that we receive for operating a business, receipts, income, also savings that are generated by doing something. So if you had a really expensive electric bill, but you managed to cut your electric costs by some sort of economizing, then a reduction in costs is counted as a cash inflow. It can be counted as a cash inflow. Outflows, the money that's going out of your pocket or out of your company, can be from costs, expenses, taxes, and we use a minus sign when we're calculating the net difference between the two. So this net cash flow is the difference between inflows and outflows. So it's revenue minus disbursements. And the end of period assumption, again, is just we say that even though it's not fully realistic, a company isn't going to only pay its bills once per year, and it's not going to only receive revenue once per year. What we'll do is we'll aggregate all of the receipts and disbursements and represent them all in a single arrow at the end of a single period. So if that becomes too much of a hassle, then maybe we'll break our cash flow diagram into months. And then that can be more realistic, as if the period is months, representing all of the revenues and disbursements as single amounts at the end of each month. Okay, so let's work on now the second piece of paper on that cash flow, the in-class exercise. So I've given you in problem 7 a list of university revenues and disbursements, and I'd like you to classify them into inflows and outflows. So just think about, from the perspective of the university, the parking fees, the tuition, and so on. Is it for them an inflow or an outflow? And then in problem 8, rather than drawing a cash flow diagram, what you're going to do is interpret it. So the cash flow diagram that's provided, turn it into a table. And then on the back side of the paper has to do with cash flow diagrams and using some of those labels and terminology that we've had so far. So I'm going to pause this recording. We've still got some time until the end of class for you to work on this, and I'll show the solution at the end just so you can see if you're on the right track. Okay, I'm going to flash some of the solution here on the screen if you want to compare what you did to what my perception was here. All of these things are going to generate revenue for the university. By the way, patent commercialization is when, let's say, a faculty member invents something and then whoever licenses that invention pays a fee to the university. But then there are also going to be expenses. And so here's a list of expenses that the university would face that's going to represent outflow from the budget. Okay, this next problem is pretty easy. It's just translating the inflows and the outflows into a table, and then the third column represents the difference between the two. So NCF, net cash flow, is inflow minus outflow. And in one of those years, there's more money going out than coming in. And so you'll see that there's a negative outflow for year 6. Okay, now last thing, we're running real low on time, so I'm going to put this on the screen in case you want to review it later after class. By the way, I'll put a link to my YouTube page on MU Online so that you can find any of these recorded lectures that you like. Review the solutions, review the lecture as you like. So you'll just have to type in the class number on my YouTube page and you'll be able to find the lecture. But here's the point of 9 and 10 was using labels. So we've got a future and a present amount. Those are the labels there. But their perspective changed, and that's why it flipped. And then the last problem is just translating a word problem into a cash flow diagram. You'll notice that I put the future amount in year 6 on top of the annual series. Rather than combining that into a single arrow, there's the annual series that goes all the way through year 6, and then a single future amount, the scrap value of the equipment of $50,000, that's a single future amount on top of the annual series. All right, we'll do more of this stuff when we get together next Tuesday. Before I let you go, I'll just put the announcements here on screen to remind you that your first homework assignment is due tomorrow by 5 p.m. And the second assignment, you can get a start on that. Even though it's not due till next Thursday, you could already start solving that homework assignment. So it's posted online. Have a good one. I'll see you next Tuesday.
Did you say you're going to post the answers to the ICE assignment online?
No.